Okay, we're going to talk about Niels Bohr, and we have a special treat for our listening audience. We have someone from Denmark here. His name is Magnus. Is that pronounced correctly? That's not pronounced correctly. I did a terrible job pronouncing that. I am sorry. How do you say it?
Magnus.
Magnus. Is that right? Magnus? Magnus. Magnus is from Denmark. Copenhagen? Where are you from?
The northern region.
The northern region. I like that, the way he says that. The northern region. Sounds very cool, the northern region. I'm from the northern region of Denmark. I like that. Excellent. Okay, so he's going to be talking to us today, a little off camera, and I'm going to ask him questions. He's going to tell us a little bit about Niels Bohr. Niels Bohr was Danish. 1885 to 1962, he worked on the Manhattan Project. The Manhattan Project was the production of the first atomic bomb. He was a little bit against it. He was not a happy camper about the Manhattan Project. He was kind of a little blackballed, actually. He was by the American government. He was not well trusted because of some of the things that he said, which I completely agree with. A lot of the scientists kind of backed off when they saw how utterly powerful the splitting of the atom is. The scientists became frightened that it could end up destroying the world. And Niels Bohr was one of those scientists who said, wait a second, this is something, we don't mess around with this. This is something we should try to put back in the box. But as you know, it's very difficult to unring a bell. Okay, so he was way before his time in terms of recognizing that nuclear power might not be something we want to play around with. And he was actually correct. He discovered, we talk about discovered Bohr model, or he invented the Bohr model. Now the Bohr model of the atom is not particularly accurate, but it's not inaccurate either. It's incomplete. It's a way of looking at the atom. It's a model that is consistent with some of the observed phenomena that we see when matter interacts with itself chemically. So, for instance, he actually won the Nobel Prize for quantum mechanics. What else was it? What did you say, Ishmael? You said he won the Nobel Prize for chemistry.
For his services in the investigation of the structure of.
Here, come up here and say that. Come up here. This is the Danish guy. Come over here. No, back here. No, back here. There you go. All right, this is the Danish guy. This is Magnus from Denmark, the northern regions. So tell us about Niels Bohr a little bit there, Magnus.
He won the Nobel Prize for his services in the investigation of the structure of atoms and of the radiation emanating from them.
And the radiation emanating from them. I like that. Very good. Stay there. Don't go away. Get some more information. Look up some more information. We'll go back to Magnus in a second. Okay. He's the responsible for the quantum theory, which says that you have these little packets. A quantum is like a little packet of energy. You have these, this excited electron. I radiate an atom with this enormous amount of energy. This unfocused giant packet of energy, giant amount of energy, undefined. And then what happens is these electrons go through these fixed transitions and give off quantum packets, and those packets are in the form of light, electromagnetic radiation. Now, electromagnetic radiation is light, and that could be, you ready? This is long wavelengths of light. Radio waves is light. Radio waves, microwaves, infrared, heat, infrared. Visible, which is actually very, very small, a very small group of wavelengths of light is visible light. Red, orange, yellow, green, blue, and violet. So it's radio waves, microwaves, infrared, red, orange, yellow, green, blue, indigo, violet, ultraviolet, X-rays, gamma rays are the shortest wavelengths, highest energy. So these transitions will produce light. The heaviest, the most toxic light, the gamma rays, are generally by nuclear transitions. When the atom releases light from the nucleus, it can be in the form of gamma radiation. Okay. What else do you got in there, Magnus?
The Bohr model shows that the electrons in atoms are in orbits of different energy around the nucleus.
So say that once more.
The Bohr model
shows
that the electrons in atoms are in orbits of different energy around the nucleus.
So the atoms orbit the nucleus in fixed orbits, and these orbits are energy related. Yes, is that what we're saying? The closer the atom is to the nucleus, the lower the energy. The farther out, the higher the energy. What else do we have? Wave particle theory of light. Is that Niels Bohr? Wave particle theory of light. Somebody said that was Niels Bohr.
Did you mention that?
No. Wave particle duality of light. Mohammed, is that what you said?
Oh, what I said was that he was convinced that light traveled with by waves and particles.
He was convinced that say that again, that electrons or...
I'll look it up again.
Yeah, he's going to look that up. We're going to get back to you on that. Wave particle duality of light. Let me just say that just for a moment, that light can be a particle, a photon, or it can be a wave, such as electromagnetic radiation, radio waves comes as a wave. He said electron plus photon. The photon is energy, a packet of energy. A photon is the same thing as quantum energy, a packet, a photon. And that is absorbed by the electron, and you get this higher orbit. Okay, you get a higher orbit of the electron, so it goes farther out because it absorbs that photon of light. Well, Mohammed, do you have anything for us? Mohammed's under a lot of pressure here to come up with Niels Bohr and the wave particle duality theory of light. Actually, a side note, as these guys are looking, Einstein did not win the Nobel Prize for relativity, but he won it for the photoelectric effect, the particle aspect of light. That light with the photons will stimulate an electron to move, the flow of energy. Solar power, the photoelectric effect, Einstein, that's what he won the Nobel Prize for. Yes, what do you have, Magnus? Do you have anything?
It's actually not only Niels Bohr, it was through the work of Max Planck, Albert Einstein, and Louis de Broglie.
What was?
The wave particle duality.
All right, wave particle duality of light. We have a bunch of scientists who are involved here. Kamal is Palestinian, wonderful person. What do we got there, Kamal? So I'm going to list a bunch of scientists who are responsible for the wave particle duality of light. Kamal.
So Christian Huygens and Isaac Newton proposed the
Isaac Newton.
And Christian Huygens.
Huygens. Okay, who else?
They proposed the theory, and then people who worked on it were Max
Planck.
Albert Einstein.
Louis de Broglie.
Arthur Compton.
Is that what you said, Compton?
Yeah. Niels Bohr.
And who else?
Many others.
And many others. So the wave particle duality of light theory was not just Niels Bohr, it was a lot of different scientists. You may want to look that up. Okay, anything else? One more thing. Yes?
Electrons should move around the nucleus, but only in prescribed orbits.
Electrons will move around the nucleus, but only at prescribed orbits. Okay.
When jumping from one orbit to another with lower energy, a light quantum is emitted.
Okay, so when it jumps from a high energy to a low energy, light is emitted. A quantum of light is emitted. You can call this light a particle of light, a quantum. Okay, are we off? Excellent. Magnus, thank you. He's Danish from the northern regions. I like that. And 1885 to 1962. Okay, and electrons and photons. Okay, that's my era. I was born in 55, so 1962 is not that long ago. Well, all right. It's a long time ago. Yeah, I know. I know. Everybody from Colorado is actually much younger than me. You're absolutely right. But anyway, so we're off. Niels Bohr, wonderful guy, Danish. The northern regions. Okay.